I just tried to join, but it failed.
Okay.
Yes, I'm sorry.
Okay, no problem.
Yes.
Okay, so basically today I discuss about that how we can easily use the InSAR data analysis. Okay, and I think I need the two lecture for completing this process because practical and also theoretical part is very complex for the InSAR analysis. So today's session I discuss about the theoretical part. Okay, for the next class I will try to show you the practical. Okay, how we can easily use the InSAR analysis. We can do the different way for the InSAR analysis. So we just follow the one way, mainly Synapse tool, how we can easily use and identify
So,
for
sir,
InSAR analysis. Yeah, please.
sorry, sir. We are going to have another class because you told me today is a last class. So if this session needs two classes, so I'm sorry. Can we have another class for completing this today session, please?
Okay, so if possible, I will try to show you that. Basically, it's also different on the data set. We need to download a software, and this software is not downloaded yet. Okay, so that's why it's a problem. So it just need a lot of time for installing this software. So I'll show you that, no problem. Okay, because for the delay for the software downloading. Okay, if the software is the opening, then we try to discuss about that. No problem. Okay, let me share my screen. Okay, basically, can you see my screen? Yeah.
Not yet. I see your son, but
Now.
no, I see your picture.
Now it's okay. Yeah? Can you see my screen? Yeah.
Yes, now it's coming.
Can you see my screen? Yeah.
Yeah.
Okay, so let's go. So basically,
Yes,
today I
yes.
discuss
I
about
see
that.
it. I see
Yeah.
it.
Okay. Today I discuss about the InSAR, basically interferometric synthetic aperture radar. And basically, InSAR is a remote sensing technique that measures the changes in the Earth's surface by comparing the two or more SAR images acquired from the same location but at different times. Suppose I want to identify basically for the earthquake, I want to identify suppose land deformation. So for that I need the same location, I need the different time images. Suppose before the earthquake and after the earthquake I need these two images. So InSAR is a remote sensing technique that measures the changes in the earth's surface by comparing two or more SAR images acquired from the same location but at the different times, and it uses the phase of the difference between radar signal to detect the minute ground movement. Okay, open with the millimeters scale precision. So this is the definition about the InSAR. It's a remote sensing technique, but in this technique we just measure the changes on the earth's surface changes. So earth's surface can be changed by different way. Suppose landslide is one kind of earth surface change. Suppose earthquake or volcanism. So different types of diastrophism technique, it occurred the earth's surface changes, and these changes we can detect by comparing two images, and these two images it the SAR image acquired from the same location but different time. Suppose post and pre, post of earthquake, pre of earthquake event, we take the image and make the analysis. So this is the insert, and basically when a radar satellite passes over the same area twice, suppose we need the satellite image that passes the over the same area twice. It send the microwave pulse toward the ground and record the return signal. Okay, the wave positive for each pixel depend on the distance between the satellite and the ground target. And by integrating the subtropical of the SAR image, we obtain the intro programming that shows the phase due to the topography, mainly surface height, then surface deformation, mainly land subsidence or upfield or earthquake or volcanism. So different types of surface deformation and atmospheric delay and noise. We just identify this type of things from this measurement change between the two images. And types of insert, so different types of we are using here. Suppose single pass insert. Single pass insert, basically two antennas observe the simultaneous, suppose SRTM, suppose topography. Then repeat pass basically same satellite revisit the area days or month later, it's the deformating monitoring. And differential insert, okay, it remove the topographic phase to isolate the surface motion. And time series insert use the multiple SAR scene to track the long-term deformation. And this time series insert, it can be two type, persistent scatter insert and a small baseline subset we also use. So basically this type of insert we use. Suppose single pass insert, it's basically identify from topography. Rapid pass insert, deformating monitoring, basically deformation monitoring of earth surface. And differential insert, basically isolate the surface motion. Suppose landslide, it just isolated from the earth surface, or volcanic eruption. So this type of things you can easily identify from the differential insert. And time series insert uses the multiple SAR scenes to track the long-term deformation or to identify. And it can be persistent, scattered, or a small baseline subset. Okay. An application, we already know about that, earthquake displacement mapping. Suppose you want to identify earthquake displacement mapping, we also use. Then volcanic deformation and uplift, we also identify. Then land subsidence due to the groundwater withdrawal, we also identify using that. Glacier and ice flow monitoring or infrastructure stability. Yeah, please.
Your screen has lost. Your screen is lost. Is lost.
Okay.
I don't see your screen now.
Yeah. Now it's okay. Huh?
Yes. Now it's okay.
Okay. So earthquake displacement mapping we can easily do using the insert. Then volcanic deformation and uplift. Then land subsidence due to the groundwater withdrawal, glacier and ice flow monitoring, then infrastructure stability, and landslide detection and monitoring. So this type of application you can easily do using the insert technique. Okay. And if you check what is the difference between the SAR and insert. So basically SAR and insert, we can easily use the SAR data in Google Earth Engine. Okay, we can easily use the Sentinel SAR data. So SAR data basically full form is the synthetic aperture radar, and insert is the one kind of technique. So it's a image, but the insert is one kind of technique. And insert technique basically it measurement the earth's surface changes using the two or more images of same area. So insert is the informametric synthetic aperture radar, and SAR basically it's work for the single image, but insert we try to use the two or more images of a same area. And it's mainly SAR basically intensity, basically amplitude, and insert phase difference between SAR images. And SAR it's a backscatter map, but insert it's the deformation map or interprogram map. And also SAR surface characteristics, basically roughness or moisture, and insert it's the surface displacement or elevation changes. And SAR basically useful for identify for floods, vegetation, soil, or urban mapping, but insert we are used for the deformation, then earthquake, then volcano eruption, then uplift, then subsidence, landslide, lot of uses. And you can see for the example tool, for the SAR we can easily apply the Google Earth Engine and make the analysis or you also use the synapse, we can also use that. Okay, but InSAR data, when you apply, we can use the GMT-SAR. GMT-SAR is one kind of open source Python package tool, or also ISC or Synapse stamps, this type of software we also use. Basically, we just use the Synapse, and also MintPy. So this is another Python package, but Synapse is more easy to use the coding. We just use the normally use the Synapse, and we can easily take the image and work with that. So now how I can get the image when you apply the InSAR technique? So first of all, you need to download the satellite images. So this is the source about that Copernicus, okay, browser. So if you check, this is the one kind of, you can simply visit this link. So first of all, you need to registration with this link, okay, otherwise it not work. So this is the basically Copernicus browser. So from the Copernicus browser, we need to registration with our valid Gmail ID or mail registration. Simply put all of this. So here I already make the registration. You can see it show my name. So I already make the registration. So you can simply make the registration to get the data from here. So after then you can simply choose your study area. Suppose how I can download the data from here, I will show you this process. So it provides that this Sentinel-2 and Sentinel-1, we can get the data from here. But in this case, we are not use the Google Earth Engine, because Google Earth Engine you can also download the SAR data, but we are not get the all of meta information from the Google Earth Engine. So we just use this browser or use this website to download the data for any study area. Suppose in this case I already have this, you can see I already choose this place and I find out this type of images. Okay, suppose this is the one image, and if you want, you can also filter your image and download for any study area. Suppose from here you can simply click on the search, and you can see the Sentinel-1, Sentinel-2, Sentinel-3, Sentinel-5, Sentinel-6. So I want to choose suppose Sentinel-1, and I want to use suppose Sentinel-1 SLC. Okay, SLC. This sensor we try to use for InSAR analysis. So select, and then go to the range. You can also put the time period. Suppose just simply put the time. Suppose earthquake pre-event or post-event. So simply choose the time. So I choose suppose January 1st to suppose you can also filter by month also. So I take suppose all of month. Okay, suppose if you need January and February, simply select the January and February. So I choose suppose all of month from here, and then I put the time, suppose last time period February 28. Okay, all of month I need the result. So now this is the way we simply choose the Sentinel-1 SAR data, and now just click on the search, and we also need to choose our study area. Okay, suppose I want to work for this any study area, it is globally available. Suppose I choose one.
Sir,
Yeah, please.
your screen is lost.
Yeah, I think it due to the networking issue or what happened.
I think it is network issues.
Copernicus. Okay, so I hope now it will work.
Yes, now
Okay.
now it's work.
Okay. So okay, basically.
So why now you have chosen SLOC instead of GRD?
So in this case, SLC, it provides the all of meta information for your image, or it give you a one file, suppose meta file. When you download the image, we find out the meta file. So this meta file we directly open in the Synapse software. Okay, and when I open, then it will be provide more information we can easily get. So that's why you simply apply the SLC. We not get the GRD. Okay. So suppose I simply need this image for the specific area. So I want to take a point. Suppose just take the point. Suppose this is my study area. Okay, I need this for this place. Okay, now just simply search and check what happened. Okay, so we find out, you can see all of image we find out for this point, basically which area cover you can see. In this case, it provide all of tiles intersection with my study area. Okay, all of tiles which intersection with my study area. So now from here you can see all of information about the image, and if you check, there is no for filtering for the cloud information because SAR is not penetrated by cloud. Okay, cloud is not hampered by the SAR imagery, so that's why you can see there is no option for filtering by cloud. Cloud is not hampered our SAR imagery. Okay, so now from here you can see this is the one image. Okay, it's covered these tiles. Okay, you can see, just click on here, then you can get the image. This is the another image, you can see. This is the another image, this is the another image. We also get the you can see information. So click on here, then you can get, you can see this is the SAR product Sentinel-2. You can see the acquisition time. So this is the acquisition time, 19 February 2025. And also check all of information. Suppose you can see the product information. Okay, all of product information. So you can see all of information. You can see that the operational mode IW. Okay, and orbit direction is the descending. Okay, and our same, suppose you take the image for the 2 time period, but your orbit direction always will be same. Suppose I just use the descending for this area, but when I take this for other image, I put the same descending. Basically we find out the ascending and descending, so we apply the same image, same location. Okay, different image, different time, same location, different time, we just apply. Okay, so now check all of those information, and from here simply download. You can see, just click on this, you can see this is the download button, and this very high image, you can see total is the 7461 megabytes. So that's why it take a lot of time. I already started the downloading, but it is still ongoing. As well as Synapse software is also download, needs take a lot of time. So that is the reason I think today is not possible to show you the practical session, because it took a lot of time to downloading the Synapse as well as downloading the one image, because image sizes is very high. So now when you download, just you can see the download button, click on the download product. So now it will be downloaded. Start the downloading. You can see that it show the part sentence. So this is the process. If you want, you can also visualize the image. So for that, you can see we find click on here. Is it network? I think some networking issue, so that's why it's not working now. Suppose that I click on here, then this image is the overlay on this section. So now from where you can easily download this imagery and also open it. So this is the first step. This is the first step to download the SAR data, and SAR data will be just same location but different time, same direction, different time. Suppose ascending or descending, same direction but different time. We need to use, suppose more image, we just simply take the more image, just simply download it from here. After downloading, we need to use a tool, and it's very popular tool. It's called the Synapse. Okay, there are a lot of hyperspectral remote sensing we can do using this tool. It's called the Synapse tool, and it also help you to identify different types of mineral or geological. There are a lot of uses for the Synapse, and it's a free of source. That it's a not the commercial. We can easily use it freely. So you can simply download. You can see the Windows version 64-bit, then Mac version, okay, also Linux version. So simply download the main download. So now it will be downloaded, and install process is not much hard. So simply just you can see when you download, simply install it. Okay, and after that simply import your 2 time period images and make the analysis. So now I simply discuss about the some how we can easily apply the insert. Okay, then you can get the after downloading, then we try to discuss about that if possible. Otherwise we need to take the session for another day, or Tuesday or Thursday. Today is the Tuesday, yeah, tomorrow is the Thursday.
Yes.
Okay, so I will try. If possible, I will check my schedule and inform you, because it's take a lot of time. Okay, yeah, okay, so it's take the time. Okay, so let me just show you that some. Okay, just I write in here. Okay, so we can also download the Sentinel-2 satellite data, Sentinel-1 satellite data also from here. But this is the problem. It's just provide you only for the GeoTIFF file. Okay, not provide any kinds of metadata of this image. So there's the region. You simply download the image from the Copernicus website. Okay, so first of all, you simply download the Copernicus website, simply registration and download it. Okay, for the Copernicus website. Okay, so first of all, we insert. So I just use it for writing something. Okay, So InSAR is one kind of measurement technique. So it's help you ground surface deformation. Okay, it's help you the ground surface deformation using radar data or SAR data. So this is the main definition about the InSAR. It's one kind of method or technique, and radar imagery must be used the same. Suppose data source, when you just talk about the data source, this data source radar imagery collected from the orbiting satellite. Suppose we can use at the Germany or Japan or US, different types of orbiting satellite, and SAR image all weather capability. Okay, so we can use at the different types of satellite, not only for the SAR, as well as we can also get the different source about the SARs. Suppose if from Sentinel, okay, normally Sentinel 1, okay, but if you want, you can also use at the different sources. And another important is that all weather capability. All weather capability, basically it works cloud or also darkness, useful during the storm. Suppose any place have the lot of storm, it also useful for also night or volcanic crisis. So lot of things it easily handle. Okay, so this is the main themes about the InSAR and how it works. So it's very important how it works. So basically two radar image we need. So first step, two radar images of the same area. Okay, so same area we taken at different time. Okay, different time, just compared. Okay, so this is the first two radar image we just take, and the same area at the different time, just compared. And secondly, the radar mainly measures amplitude, okay, and thirdly it create the differences in phase reveal surface movement toward or away from satellite. Okay, and finally combine image. Finally, for this step, combine image, show the deformation pattern. Okay, so this is the work. Suppose first of all I just suppose anything. Suppose using this process we can easily monitor anything. Suppose you want to monitor earthquake deformation, or suppose landslide, or we can also do suppose subsidence, or volcanic eruption, or also uplift. So any deformation or any deformation of earth surface we can monitor. Okay, any deformation, suppose any place have the earthwork, so now you want to identify suppose deformation map, so simply take the before and after earthwork imagery and apply the same process, then we display the deformation pattern we can easily identify from this image. Or anything, landslide, subsidence change, or volcanic eruption, volcanic uplift, lot of things it also possible using the InSAR technique. Okay, and a deformation map showing how much the ground move between the image acquisitions. Okay, so final output we find out the result. So basically this result it display the result, deformation map. It show the how much ground how much ground moved between image. Okay, so it show the how much ground moved. So these are final output or result. And how I can check the accuracy about that? So it can detect the change on the centimeter scale, okay, over a large spatial area. So that's why you find out the very high accuracy about that, because it estimate the scale over the large spatial area, because it can detect the change on the centimeter scale, okay, over the large spatial area. Suppose I have a big study area, but it can detect the change on the centimeter scale for in InSAR technique. Okay, I also mention about that. It can be detect the changes on the centimeter scale on the large scale area over the large scale areas. Okay, so this is the theoretical part. So I also send you the one website, you also try to read it, then get a lot of idea. So this is the one kind of website from the NASA, USGS. So insert satellite based technique capture overall deformation. So you can also get the idea from here. So you also read this type of thing, then you can get a lot of idea, mainly theoretical part. So monitoring ground deformation from space, we are just use this type of technique. So then you can get the different types of mapping. It also possible to create using the insert technique, mainly interprogram image we can use, and then use this type of things from here. So I'll just send you this link also, you also try to read, then get the idea how to work with the insert.
Okay.
And finally there's a lot of advantage we find out when you apply the insert, because insert is very tough because there's a lot of way. But I will try to show you the synap, but synap is not only for that, we can also apply the different types of Python package also, but it's more complex. For the Python package we need to install the Linux. Okay, so this type of things we need, but the synap is very easy way, we just simply use it, the synap, and we can easily use this type. If you want, you can also explore this type of things. I'll show you the guideline. Suppose gm basically gm package. Just a minute. Okay, it's loading. Okay, you also try to read this PDF, then you can get about that how to use the Python package. And there's a lot of application we already know about that. Advanced basically monitoring inaccessible or hazardous volcanoes on terrain, okay, or provide the wide area coverage, okay, not just point measurement, and support long-term deformation, okay. We can easily identify for the long-term deformation, okay, and we can easily identify, suppose volcano activity monitoring, okay. Suppose any volcano or any volcanism area, we can easily monitor using the volcanic activity. Now what's happened for the volcanic activity, we can also monitor, or also earthquake deformation analysis, okay, and also landslide detection, groundwater destruction, and the subsidence tracking. So these type of things we can also do. So this is the one kind of guideline or process. I'll send you the book. You also try to open and then you just try to do. You can say GMT installation and pre-processing guide practical, okay, practical InSAR handbook. You also try to step by step. I hope it also okay, but it's a lengthy process, okay. You can see the install also in the install flow, okay. Lot of package we need to install when you work with the GMT sir, or also install the Synapse, Google Earth, Sentinel-1. So it very popular book to work with GMT sir, okay, but more complex, okay, more complex. But Synapse tool is very easy way. We simply download the data and we can easily do it, okay. So I also send you this practical book also, so you also try to read and then check, and there are a lot of topic it's covered, okay, for the practical cover. So step by step you try to read it, then I hope it also help you to my idea. And one process I will try to show you that further inshallah next class, after downloading my Synapse tool, okay, and also downloading the two satellite imagery, SAR imagery, and how we can easily use, okay, then you can also get the better idea. Okay, so in the meantime, I will also send you this book and also send you all of information for today's session. But practical session, inshallah, I will show you that next class, because you can see it also takes a 6 hour lab. So I think some networking issue from my side. That's why it take a lot of time. Okay, I would downloaded this software and also downloaded the two SAR images to show you the process using the Snap, inshallah, for the next class. Then you can get the more better idea. Okay. Okay.
Okay. Sir,
Yeah, please. Any question?
now, sir.
Yeah, please.
So when will we have next class?
Okay, so basically today is the Tuesday, Thursday I have the class, then Friday, Saturday, Sunday.
Sunday.
Yeah, Sunday.
Okay, so now I have two issues. I want you to help. I want you to help me.
Yeah, please.
One is I tried to sign in order to access the data from NICFI.
Yeah.
NECF.
So basically it's from the
NICFI.
planet data.
Yes, from Planet, but it fails. I signed up, they sent me the email, but I want to access to.
Okay, kindly show me the
Show me
your screen. What is the problem?
Okay, let me share my screen. Okay. Okay.
Yes, I can see your screen.
You see?
Yes.
Okay. You can see my screen, sir.
Yeah, I can see.
Okay.